welcome to Demystifying AI and AI Product Management. In this session, we'll start off with some really quick introductions, and then I will let Deepak take it away. I'll also kind of share some really quick reminders for those of you new to the platform before we get started. So, hi, I'm Robin. When I'm not emceeing for Elevate, I am the Director of Product for Scribd. If you haven't heard of it, it is sort of like a Netflix for ebooks, audiobooks, podcasts, user-uploaded documents. And so I work really in the space of looking at, over 200 million documents. How do we find the right recommendations for the right users at the right time? So very much in the AI realm, leveraging machine learning across a lot of unstructured metadata. So really excited to hear from Deepak, who I will let, who is an AI product leader, ex-Microsoft, but I will let him introduce himself.
Right. I'm an AI product builder. I have some slides to share with you. I'll quickly get started. Right. So hope you guys can see my screen all right. Robin, is this showing up correctly? Right. So what we were talking about today is AI in product management. What happened there? Don't know what happened. Always the first time for anything.
Okay.
I don't know why I can't share. Not able to move the screen. Just a minute. I'll just open it up. Right. Maybe this works. Right. So just a standard disclaimer for people to take a look at. So we'll cover 3 topics today, just demystifying AI a little bit, my views on AI, having worked on it for so long. We'll try to get into a hands-on exercise. And then lastly, I'll help you with some resources that help me succeed. Hope that you succeed, helps you succeed. So this is a little bit about me. Not a math wizard. I wouldn't rate highly on a Mensa score. Don't have a particularly high IQ. Just sheer persistence is all I take away. But more importantly, if anything you take away from this, I can do it. You can do it too. So what do? I built AI products. So three different kinds of AI products I built in my career so far. One was a machine learning based prediction product. The other one was based on natural language processing, content extraction, content classification. I also tried to build a comedy bot, which could take cues from the audience and tell a joke. The fact that I'm still working tells you exactly how that went. So I won't talk about it as much. The last piece of work I did at Microsoft was building a consumer application, which was human facial expression recognition. This is what I do. But during the pandemic, I asked around, what others think I do. So on the left, you see my wife. She thinks I talk a lot. That's my kid next to her. He thinks I laugh a lot. If you ask my developer friends, they'll tell you I negotiate a lot. And if you ask my customers, they'll say he persuades a lot. And the person on the right is a mix of a manager, a mentor, an HR person, a lot of friends. And what do they think? What do they think? He doesn't do a whole lot. So that's what you'll get if you ask around people. So let's get into the facts now. What is AI? So I've taken 2 examples, human intelligence and artificial intelligence. You see an object on your screen, you look at it, looks like an apple. You touch it, looks like a real apple, not a wax apple. You smell it, it looks like an apple that smells good. So would you want to now eat it? But if I showed you this picture, and if you knew of the biblical mythology, you would think I shouldn't eat the apple, not even on the other side. But would an artificial intelligence know that? Would it understand the full context of the apple and the snake and the biblical idea and get the point of eating the apple or not? So a lot of AI is context based, is an understanding of the world that will help you shape the decisions you make. Taking a little more concretely, this is the best way I can explain to others what AI is. For example, traditional software uses inputs, uses algorithms to generate an output. Whereas AI uses an input, the output of the world we're trying to model for, and what it creates is an algorithm to solve for the unseen. For example, if I were to feed the images of cats and dogs and parrots, I'd have to feed the algorithm. If the cat has eyes and whiskers and night vision, then it's a cat, also it's unknown. So when the output, it does classify the images of cats it has seen before, but on previously unseen images, traditional software fails. Whereas in the case of AI, you give the output, you tag images of cats as cats, and the rest as unknown. In this case, the algorithm is now able to function and then tag unseen images of cats as cats. So the learning is in the algorithm, and that's what AI uses. So, how does a typical AI team look like? This has been my experience by and large. So, there is always this element of the math, the software, and the human element. You'll have statisticians, you'll have programmers, and you'll have someone like me who understands a little bit of everything, but is mostly interested in the human aspects of the AI. And what are the kinds of AI products that exist today? Been fortunate enough to build all of these. So what's on the left is the pre-AI product, which is in the most repeatable. It has the most number of clicks and buttons and features to get the work done. It still solves a user need, but there's a lot more user effort involved. Whereas for AI inside products, the product still works, but the effort required is now lesser. Now, to make for the effort lesser, you try to get many features in, right? Because you want to simplify workflow a little bit. Instead of 20 clicks, you'll have 10 clicks. When you go to the AI first solution, you're now at a phase where you optimize the solution so much that you need the least number of clicks to get there. Imagine Alexa. As you know now, the software features that come on Alexa, you're now able to get to the answer in much fewer questions. You're now able to have the machine answer sophisticated questions it couldn't answer before. This is because it's been fed with data, it's been fed with AI features. There are fewer questions required to get to the answer. So what about an example, right? So let's take this website called Sell My Home, right? This is a home that's quite close to where I live. They want to sell this house, right? And we're now going to role play how a product manager would look at this AI, as an opportunity to build a product or a feature, right? So remember, you are a product manager for Sell My Home. You have to launch 2 new features that will help, Robin the seller sell her home. And let's try to see what we can do for Robin. So for Robin, we want to provide 2 features, say. So we'll say, for $4.99 a month, the moment you start listing, would you like to know when your property will be sold? And for an additional $3.99 a month, would you like to know for how much money your property will be sold for? Because that's what sellers are looking for. How much will I get for the money? How long can I wait for it? And these 2 are important questions to answer, because the longer you wait, the hypothesis is you may be able to get more money for it. But the longer the house stays on the market, the house may become a little more stale and may not get the money you need for it. So in these 2 scenarios, in these new features, let's look at how a typical machine learning project will look like. So let's take the first example. This is how a typical machine learning variable selection would look like, to the model. In the first question, the question we're asking is, will the house be sold in the next 90 days? This is a binary outcome solution. We're looking for an answer yes or no. And what you see on top are the various features of the house. For example, what's the house ID? That ID may be 101. How many rooms does it have? How many bedrooms does it have? Does it have 3 bathrooms? What is the square feet? Is it a flat? Is it a semi-detached house? Is it a detached house? Is it a bungalow? Is it new? Is it freehold? These are all very London-specific terminologies. But all we're trying to say is the house available to be sold immediately? Is there someone else trying to hold the hooks onto it? So for this kind of a question, because it's very, very binary in nature, will my house be sold or not, we'll use what we call logistic regression. Now, let's look at the same data. Let's ask the other question, looking at the other feature. What price will it be sold at? Again, you have the same data, the house ID, the rooms, the number of bedrooms, 3 bathrooms, the kind of square footage you have. Is it a flat? Is it semi-detached? The same variables. But now the question you're asking is it going to be sold and for what price? In this case, the price is a continuous number. You're looking for a value, like you saw on the website there, it was listed as 1.2 million pounds. But the question now becomes, is it going to be 1.2 million, or how much is the range over and above? In that case, it's a continuous variable. The spectrum of answers is much, much longer. In that case, you're looking to solve using a linear regression problem, because you're trying to predict a number at the end. Again, the data is the same, but the question now becomes, the question I'm answering is different. Now, how would we do that? What you see now is how a typical AI project works. It all starts with the data there, no surprises. What you do now is you take the data you already have. For example, in that case, you saw data for one house. You now look at data for all the other houses that you've sold so far in that location, using the same square footage and in the same vicinity. You take the data and you'll say, okay, I'll take, say I have 100 million rows. I will use, say, 90 million to actually build the machine learning model, and then say, okay, I have a hypothesis now that this house will be sold in 90 days or not. Now you'll test it. You test it with the actual data of the houses that were sold to say, okay, did it actually happen or not? Now, this is a continuous process because you want to make sure that this data is working well for you. If that model works for you, then you deploy and then you train the model. Then you test it. And if it doesn't work for you, you keep on retesting. For example, you might figure out that the data points you use to build the algorithm may not work for you. For example, we thought a number of bedrooms was a key criteria. Turns out, distance to the closest tube station was a far important factor than number of bedrooms. So what do? We retrain the model, include that variable in, and then see what kind of outputs we get. But in all of this, because it's a dynamic nature, there is always an event such as the pandemic, where the house prices rocketed in the UK because more and more people realized that they wanted to live in a house that they wanted to live for a very long time. They don't want to live in matchboxes, in flats, where they didn't have much square footage to deal with. So for that external factor, the prices of the houses shot up no matter what. Well, we can't control for those black swan events. But what we'll do is we'll try to look at the data, come up with a model, and see how it can be done. So let's just say for our purposes, we built a logistic regression model, it gave us the solution, and then we deploy it. What you see there is an actual example, code example of how one could go build it. There's not much time to go through the code here today. But what you see here is a sample of what the data will look like. So if you see that there are 5 data points, you have 5 different houses. You see the kind of a lot shape the houses, regular shape. Is there an alley there or not? Is there a pavement or not? Or you also now see the lot area, this kind of square footage the house has. Let me tell you, someone has a 14,260 square foot house. That house is not selling for 1.2 million. You add a 0 at the end. That's how much the house is going for, because this is a very big house, and needless to say, they're going to make a lot of money when they sell it. But also look at the lot frontage. How much area do they have in front of the house? Once you have the data, you want to figure out, well, what is the ballpark? How is my data distributed right now? Because we're training. So the first graph you see there is the living area. You now want to see, okay, given that living area, what are the kind of prices I'm seeing? So if you see there now, your prices are kind of correlated around this 1,000 to 3,000 square foot of living area. And you want to now see, okay, how does my data distribute? So as you can see now, there are some outliers. For example, some houses have 4,000 square footage and they're selling for upwards of 8 million. But slightly more, and the houses are selling for only 2 million. Again, that itself is not an indicator. We need to look more. So if you look now, you'll see garage area. Is garage area important? So you go through this model of figuring out what are the variable factors that go into predicting this model. And then when you come back to your prediction and you come back and help Robin or someone like them to sell a property, you say, okay, we churn the data for your kind of house. We'll tell you that your house will not be sold in the next 90 days. We think it'll take much longer. And if you take the additional model, we'll tell you, we think given the current condition, we don't think it'll sell for 1.2 million, it'll go for 1.1. But the crucial factor is, because we now have data about how does the data compare to previous history, we can tell you what you need to do to get to the sweet spot of selling the house soon enough and adding more features to it so that it sells better. For example, whatever those folks are doing there who sold their house for 7 to 8 million with just 4,000 to 5,000 square feet of area, we need to learn a lesson from them because they're doing something really special. So then we can now build a feature that can tell them, here are the things you could consider doing, because we've seen other users like you who done with these features have sold the house for a much higher price and were able to sell it much sooner. So what are the key takeaways? The key takeaways for me are that AI products are data hungry, where other products are looking at creating data and ending there. Transactional products such as airline reservation, train reservation, cruise ship reservations, these products need that data to run. And when no data input is input to them, they die. So for example, sell my home, if there is no transactions there, the predictions become stale and they don't work very well. So those features will not work. But more importantly, they're as biased as the humans creating them. So if you're not able to pay attention to who sold the house, in which locality they are, then we should consider those variables to include in the prediction. So lastly, what are the learning resources I can share with you? These two books, in my mind, are the seminal books on AI. I cannot recommend them enough. 21 Lessons 21st Century by Yuval Noah Harari just gives you a deep insight into AI and what it means for the 21st century. I'd also recommend Homo Deus if you had the time to read it. And Life 3.0 by Max Tegmark paints a very surreal picture of what a really intelligent AI could look like. I mean, that he paints a very vivid and scary story of how an AGI could come to be. Courses on AI. Now, these two are the ones that I've actually taken, and I have loved them. Andrew Ng is slightly dangerous in that he makes you think that you understand AI and machine learning. After I finished the course, I felt I could go and conquer the world right away. That's how beautifully he explains it. But the underlying math is so hard. Rubber hits the road, you're sure you can't do that much. But leave it to the master to teach you machine learning and get you a good sense of intuition around it. He also took the data science course by Johns Hopkins on Coursera. And between these two courses, it'll give you a very good idea of machine learning is and how you can use it in your product journey. So that's all, folks. That's all I had to share today. I'll now hand it back to Robin for any questions she has for me.
Hi, thanks. I'm so happy to know that I have such a beautiful house to sell. Thanks. I really appreciate your presentation. I have some questions from the audience, but I had one myself first, which is sort of, in your experience, you mentioned sort of how, when is the right time to incorporate AI, and you have this kind of spectrum. Where, from a product perspective, when so much is unknown, how do you think about justifying the investment of time when the outcomes are so uncertain?
That's a very good question, and I faced it so many times. So as you know, this is famed graph of data and the ROI and the time. You go from diagnostic, descriptive, predictive, prescriptive in that whole journey. As a cliche, that's a cliche, but it's absolutely right. You have to first nail your diagnostic and descriptive elements, then go to predictive, prescriptive. So I would say, if you have not been able to say, look, let's sell my home, for instance, if I've not been able to take a look at the data, do the maximum out of it, diagnostically and descriptively, then I won't have a culture of data-driven decision making. Then it'll be a much harder sell to say, let's do some AI, let's do some prediction, let's do some prescription. So if you have maxed out all your diagnostic descriptive capabilities from your data, then it's a much easier sell. Of course, you need really smart people. You need smart people who are, this is the best logistic regression model I can build versus this model actually helps people sell the house. It's 5% less predictive and less accurate, but it's actually very, very useful. So you need some people there who are okay with lesser accuracy, but are high on usability. Top of my mind, I would say those two are key important things. First, have you maxed out all your BI capabilities? And two, do you have the right people asking the right questions and campaigning behalf of the customer?
Yeah, I think that's a tricky part because obviously not every company has their own dedicated data scientists on staff to kind of help. And so it's a little bit of a framing, and it can lead into a build versus buy scenario. And so making sure you frame that in the first place is really critical. So I have another question from the audience. Is AI really the future, or just another buzzword? So, there's Apple, who invested really heavily in Siri, but a lot of what it's really used for now is timers and messages.
Of course, I'm going to be biased when I say yes, and there's a good reason for it. The one slide I didn't show you is this slide from Stephen Wolfram. He made a very interesting comment that AI can replace anything that you can automate, and you can automate anything that you can describe. And that is absolutely true. So if you're able to describe the journey of a customer, of a user, left to right, back and back to front, from start to end, you're now able to tell a very good story. Once you're able to tell a good story, repeatably, scalably all the time, you can easily automate that with AI. Because as I just showed you, AI has this good ability of abstracting, learning from previous patterns, and abstracting for unseen, unknown patterns. It's never going to be 100% correct, but a good sense of abstraction will always help. So I say, yes, definitely. AI is going to be the next big thing. Like you were saying, Robin. Yes, I've been privileged where I had my own in-house, in-staff people, data scientists to help me out. Other people don't have that opportunity, and it'll come. That will come where this kind of culture of data and AI will be embedded into the company, and the cost parameters will become lesser. Every product will be an AI product because every product will be a data product. Yes, I've started using Apple, and I can tell you, yes, it looks like that. They're just using timers and whatnot, but man, are they intelligent? Like the data privacy they have on the data they store, data they share, and the experiences they surface based on it. All the facial recognition features they have, the facial authentication they have, the kind of AI they use on their chips, on their device is cutting edge. So, so those are, I would say, good examples of bad AI, but there are very, very good examples underneath as well.
Yeah, I totally agree. And also, I think it's a new kind of interface. Being able to have voice interaction, all of that is something that's still being worked out. So, what are the inputs that are being given? Another question that I have is actually kind of tying together a previous session with a question here, which is sort of when you think about ethical AI, and you mentioned here again the importance of the inputs and the data labeling. How do you try to prevent the the incursion of unconscious bias within artificial intelligence?
Well, I have a whole presentation on that I couldn't do here, but the computer vision product I was talking to you about, that was all about human facial expression recognition. Human means women. And if there was a poster child for not having enough gender diversity and failing massively, that project was that story. Because guess what? I am not good at reading women's faces. No man ever is, because women understand women better. So we spent an inordinate amount of time collecting data, annotating faces, and building machine learning models. Guess who was building them? Men. So yes, you can read blogs, you can read papers, but a lived experience is completely different than a heard experience or a taught experience. So I would say, if you want to build products for the world, then the world must be involved in building it. The world must be involved in building it. If you want to build products for women, you must have women on the team. If you want to build products for different ethnicities and diversities, they must be represented, because there's so many nuances that they can't appreciate. Give you one quick example. So this is one use case we were trying to figure out: how do women express themselves in different environments, controlling for their ethnicity and age. And what we found was that Asian women express themselves far, in a more exaggerated manner in developed countries than in a developing country. Guess who told us that? A woman of that gender, of that ethnicity told us that. We would have never figured it out. We would have never noticed it. So that kind of person being in the team, helping us out, looking at those nuances, helped us out. Otherwise, our machine learning model would have said, X in USA is smiling, the same X in some other place is sad. That is not true, just that the environment is different. So I would say the biases are very, very high depending on your application, but you will do less things wrong if you have a diverse team building that AI for you.
Yeah, that's a really interesting story. I think it's also a matter of where is the diversity, because I think, as you were saying before, it's also what, even when you're labeling, somebody has to determine what is it that you're labeling for, what are the definitions, what is being captured here, and so it's kind of involving making sure that you create the culture and the structure throughout, so that you not just have them on the team, but you have a way that they can contribute and that they're shaping from the very beginning, and not just looking at the outputs at the end.
Yeah, and you were asking the questions in the previous session about bias and inclusion. I was nodding my head all along. Absolutely right. Yes, AI products are a shining example of a negative impact of not building AI right when you don't have diversity. You cannot get a more clear explanation than that.
Well, I want to go to one last question, which is sort of, do you have kind of general thoughts on the metaverse, or kind of what the future holds?
Well, metaverse is a fantastic idea. It gets to you're able to now simulate realities that you can't exist in the real world. It can also help you transport yourself there. It definitely has a great potential. My only caution, as with AI or anything else, is shouldn't replace the human experience. Yes, we are more productive being at home, but you do miss the human connection because you are not born on Zoom. You are born in the real world with 3D people interacting all the time. So Zoom is not the interface for everything. There are some things you can do really well, but a real human experience, a real touch and feel is an entirely different thing. So I would say there is definitely great scope. It'll be a learning curve to get there. But for use cases such as remote learning and collaborating, metaverse will be great. But being humans born in a human world, not in a metaverse, I would still think we'd have hard trouble indexing and moving to the metaverse from the real world.
No, that's a really interesting perspective. I think it's funny on one hand for all of us to be kind of Zoom fatigued and kind of craving that in-person interaction, but on the other hand, developing the future in this metaverse and understanding, trying to think of new ways that you can kind of interact and bring, whether it's via Oculus or via some other kind of wearable where you're out in the real world. What is that transition like from this conversation, which is 2D but very interactive, to the other people who are surrounding us? So I think that it's a really exciting time.
I'll sign up to metaverse the moment they can get smell in, because I want to smell what's cooking in the movie, and I'll be very excited because it's a very good mechanism to build empathy. I'm not only able to see you, but if I'm able to be transported to where you are, look at your surroundings beyond your 2x2 screen, I'll empathize you much more. It definitely has that power. But like I said, how much do you want to share of your world? Are you okay sharing everything outside your 2x2 screen? Maybe not. There's a lot of toys over there you don't see. It's my kid's bedroom. So there's a very good question to answer there. But yes, I see the potential. There's definitely value in the metaverse.
Should I ask one more question? Or no, I think we're pretty close to time. So thank you so much. This was really fascinating. Really appreciate all of your insights. I know I didn't get to all of the questions, but do feel free to connect with Deepak and ask him outside of this.
Excellent. Thank you, Robin. Thanks, Plateau team.